My name is Julia, and I am a fifth-year MD-PhD student at UCSF. I work on embryonic stem cells and trying to understand how they're regulated by a class of molecules called RNA-binding proteins. This is important because embryonic stem cells have a lot of therapeutic uses in terms of disease modeling and regenerative medicine. They're also great platforms for testing drugs for conditions that affect specific types of cells, because embryonic stem cells can become any cell in the body. So I was born in China, and my family and I came here to San Francisco when I was 3. So I grew up here in San Francisco, and my parents were both doctors in China, but when we moved here, they got into science as well, research. So I guess I've had a lot of exposure to science and medicine growing up, which was a positive influence on me. I also have always been curious about most things, especially about science. I enjoyed watching things like Bill Nye the Science Guy and Magic School Bus when I was younger. So I went to college in Boston at Harvard, and so that's a very different environment. It's a great place, and I have a lot of great friends and a lot of great mentors there, but I pretty much wanted to come back to San Francisco that whole time. So I got in here, fortunately, and so I think it's been a really great decision. Biomedical science is interesting because it requires a lot of different skills, and the average day can be pretty variable. It generally involves a lot of experimenting and doing stuff at the bench, pipetting, using pipettement, and there's also a lot of data analysis. You have to take the time to summarize your data and integrate it and write it up. You're also constantly reading up on the literature to get new ideas on how you should proceed with your own research. Lots of meetings with the lab and other people to help you move forward.
You know, I've been using this antibody recently, and
so like I said earlier, embryonic stem cells are really important because they can make all the cells of the body, and so therefore they're useful from a lot of clinical perspectives and from making drugs, and for also making new tissues for people who have a disease of a certain cell type. I guess truthfully, it will take many years for the stuff that I'm doing right now, understanding the basics of how embryonic stem cells work, to have a direct impact on a patient's life. But biomedical science is very incremental. It's all about little small steps, and it's hard to say when a small step becomes a big thing. So in the distant future, I see my work on understanding how the basics of these cells work, possibly helping a lot of patients who have all sorts of different diseases, from developmental disorders to people with, for example, ALS, who need to have new neurons. Biomedical research is important to me because it ties straight into advances and therapeutics in the clinic. One other thing that I'm particularly interested in is education. I've always felt like I was very blessed to have really dedicated and great mentors throughout my life. I was very lucky. So being a good mentor and teacher has always been very important to me. So I actually, 4 years ago when I came to UCSF, started a science research program for one of the local high schools, my high school alma mater, Lowell High School. So I've been running that for the past 4 years. I'm really proud of the science research program that I founded. I wouldn't say that I'm naturally a super outgoing person who is a natural born leader, I guess. But through this experience, I've learned a lot about myself, and that I can be a leader, and that I have a very strong interest in science education and seeing young people become interested in science and getting their first taste of science research. I really enjoy being part of their process and feeling that I have helped them take their first step into what could possibly be their future career. So I'm very proud of that. you.